Hello, welcome to Pre-Cal Lecture 2.7, where we're going to work some quadratic motion problems. So you have some pre-printed notes for this section. So let's get right into it. Our first example is a student drove to see his friend. He drove the first 105 miles of the trip in an hour more than it took to drive the last 90 miles. The average rate of the last 90 miles was 10 miles an hour more than the first 105 miles. How long did it take to get to his friend's house? Okay, so with these motion problems, how long, what we've got here are the distance equals rate times time problems again. Only this time, we're going to end up with an x squared when we go through the solution. So let's draw a little timeline here. Let's say we're going west to east. All right. And the first 105 miles and then the last 90 miles. So the first 105 miles, I'm just going to say the rate is r and the time is t. And then we know the last 90 miles kind of hit the accelerator and the rate is r plus 10, and the time it took was an hour less than the time it took for 105 miles, so it's t minus 1. Okay, so let's make a distance equals rate times time chart here. And we'll say the first leg of the trip was 105 miles. The second leg is 90 miles. We know the rate is r. We've talked about that. We're just going to give it, and the time is t. So we always like it if we can to have an easy one, just a distance equals rate times time for one of them. And then the 90 miles, it's r plus 10 and then an hour less, so t minus 1. So we have two equations here. 105, distance equals rate times time. 105 is equal to r times t. And 90 is equal to r plus 10 times t minus 1. Now what I want to do, I'm trying to solve for how long. I want to know t. So I would really like t's to be in the final equation. Otherwise, I'm going to have to make an adjustment at the end. So if we solve for r equals, so I'm going to rearrange this. R is going to be 105 over t. Now I can plug that into r right here. And all I'll have is t's in the equation. If it asked for the rate, then I would solve for time. T is 105 over r and plug that in for t. But you want to get the correct variable in your equation. So we have 90 is equal to 105 over t plus 10 times t minus 1. Okay, now we have an equation with only one variable, time. So I'm going to FOIL this part out right here. So I've got 90 is equal to 105 over t times t. The t's will cancel, and we just have 105. So that's the first. And then we would have minus 105 over t, that's the outside, and then plus 10 times t, that's the inside, and then finally minus 10, that's the last. Now I want to get rid of this fraction, get rid of the t on bottom. I can do that by multiplying both sides of the equation by t. So I have 90t is equal to 105t minus, and this was the whole point, t over t here will cancel, and I just have minus 105, and I've gotten rid of the fraction, plus 10t squared minus 10t. So we've got a t squared in it. That's where our quadratic comes in. Okay, let's set all this equal to 0. So we've got 0 is equal. I'm going to move the 90t over to the right. That'd be negative 90, right? So I would have 105 minus 90. That's 15 minus 10. I'm going to have a 10t squared. And then plus 5t. Because 105 minus 10 is 95. And then minus the 90 would be 5. Minus 105. Now I could simplify this down a little bit, and maybe that would make it easier to try and factor. Let's divide both sides by 5. If we did that, we would have 0 is equal to 2t squared plus t, and then 5 will go into 120, so minus 21. Let's see if we can factor that. Because if we can, I don't have to fool with the quadratic formula. So I've got 2t and t. That part's easy. Well, with 21, we've got 21 and 1 and 7 times 3 as our factors. So I'm thinking 7 times 3 is what I should try. So I could, if I did a plus and a minus, I've got 2t squared plus 17 minus 6t, that's t, and then minus 21. So we could set this parenthesis equal to 0, 2t plus 7, and then 0 equals t minus 3. So we would have t is equal to 3 as one of our solutions, and t is equal to, if we move the 7 to the left side and make it negative, divide by 2, negative 7 over 2, right? So negative 7 over 2, we can't have that, right? It's because that you can't have a negative time. So, but we've got 3 4t. Now, don't circle that, because the question says, how long did it take to get to the friend's house? Well, this is how long it took. 3 hours is how long it took to get 105 miles. So it's going to be for the whole journey, and this is what you have to be careful with on these types of problems, is what is it asking for? So it's going to be t plus t minus 1. Because for the 105 miles, first 105 miles, you're going t. It takes t in terms of the time. And the second 90 miles takes t minus 1. So that's going to be 3 plus 3 minus 1, which is going to be 5 hours. So a lot of students will circle, they'll get that answer and they'll be excited. Hey, it's 3 hours. No, read the question. It's the whole journey. All right. So that's pretty cool. Maybe a little bit complicated, but it's a lot like the ones that we did earlier in Chapter 2, where it wasn't a quadratic. Okay, let's do another example problem. We're still in 2.7.1. I accidentally erased the title there, but that's okay. So for this next example problem, it says it takes Joanne 1 hour longer to hike up a 6-mile trail than it takes Lisa to hike a 5-mile trail. If Lisa hikes 2 miles an hour faster than Joanne, how fast does Joanne hike? Okay, well, let's make a distance equals rate times time chart. And we will label it as Lisa and Joanne. We've got distance, rate, time. Okay, let's read through it. So we know that the distance, so Joanne is hiking a 6-mile trail, and Lisa is hiking a 5-mile trail. So that part's easy. We want to know how fast does Joanne hike? Okay, so I'm going to give her the R because we want to solve for r, and we're especially interested in Joanne's r. So what I usually do is I want one of these lines, one of these horizontal lines, just to be a distance equals rate times time, a simple one. So I'm going to go ahead and give Joanne the t. Lisa now, if you read it, is hiking 2 miles an hour faster than Joanne. So that's r plus 2. And then the time it takes Joanne 1 hour longer. Her time is 1 hour longer than Lisa's, so Lisa's time would be t minus 1. All right, so you could do it a different way and make this r minus 2 and t plus 1 and give Lisa the rate times time, but then you're having to make an adjustment at the end. I like to set it up so that I'm making no adjustment at the end if possible. So here we have 6 is equal to RT, and we have 5 is equal to r plus 2 times t minus 1. Okay, we're trying to get only r's in our final equation. All right, so 6 equals RT. How about we solve for time? Time is going to be 6 over R, and now I can substitute for T right there. So I would have 5 is equal to R plus 2 times 6 over R minus 1. Now we've got only R's. So 5 is equal to, let's FOIL, R times 6 over R. The R's will cancel, and we just have a 6. Then we have R times negative 1 would be minus R. And then this middle term would be plus 12 over R, because 2 times 6 is 12 over R. And then finally minus 2. So we just FOILed all that out. Now let's get rid of the fraction by multiplying both sides by R. So we'd have 5r is equal to 6r minus r squared plus, and this was the whole point, r over r cancels and you're just left with the numerator, plus 12 minus 2r. Now I like to have the squared term be positive, so I'm going to pull everything over to the left. So that makes it a positive r squared, and then we would have 5r plus 2r, that's 7, minus 6, so it would be plus r, and then minus 12, because I'm taking that 12 and moving it to the left, equals 0. All right, just go through that however you want to do it, but I kind of am an eyeball man, all right? I'm moving this over, making it negative. 5 minus 6, then negative makes positive, plus 2. Negative r squared to positive r squared. So I'm an eyeball man. Now we're going to try to factor. So r, and then 4 times 3 makes 12, and that could give me a 1 in the middle. So plus 4 minus 3. Okay, so the rate, there's two rates that would make this 0, right? Negative 4 and positive 3. Right? Negative 4 plus 4 is 0. 3 minus 3 is 0. Now, which one are we going to cross out? Well, you're not going to have a negative speed. You can have that in physics, but it denotes direction, and we're not really doing that in this class. And this is in miles per hour, right? If we look at it, 6 miles, so it's 3 miles per hour. And I don't have to make any adjustments because we wanted to know Joanne's rate, and that's why we put R in for rate. We're solving for R, and we can stop right there. All right, so the way you set up the problem can save you a lot of trouble at the end of the problem. So keep that in mind when you're setting it up, because you can set these up multiple ways. All right. So if you will go to the next page of your notes, we'll talk about the quadratic projectile problems. These are a little bit simpler, except we're going to have to use the quadratic formula some. So our first example is a baseball player throws a baseball straight up into the air. the formula for the height h of the ball after t seconds is h is equal to negative 16t squared plus 48t. How high is the ball after 1 second? So we have h is equal to minus 16t squared plus 48t. We want to know the height of the ball after 1 second. So with function notation, what we're trying to find is h of 1. Hopefully you went over that in your Algebra 2 class, h of 1. So it's just a plug-in problem. Negative 16, we're going to plug in 1 for t. So plug in 1 for t. That's what function notation means. So negative 16 times 1 squared plus 48 times 1. Okay, this is just a nomenclature so you don't have to write that out. We can say h of 1. That's just a shortcut way of saying that. So that's 16 plus 48. So the height is in feet, so that would be 32 feet. All right, great. So it's an easy one to get you used to these kind of problems. All right, number 2. Our second example says, a disgruntled pre-calculus student boots her notebook across Joe Estes Gymnasium. The flight of the book is described by the position function s is equal to negative 16t squared plus 88t plus 2, where s is in feet and t is in seconds. How long is the book in the air? Okay, so we have s is equal to negative 16t squared plus 88t plus 2. So what this is saying is the height of the book, or the position of the book, really, but it's the height of the book, is equal to this equation, and you just plug in a time. At what time? Now, what's the height of the book at the end of the flight? Well, it's going to be 0 because it's going to be on the floor. S equals 0 at end of flight. So we want to know how long is the book in the air. So we want to solve for time when s equals 0. All right, so we'd have 0 is equal to negative 16t squared plus 88t plus 2. Now, this is, I can tell you now you can't factor that, so I'll save you a little time. We could divide everything by 2 and make the number smaller, but you have a calculator, so I'm not going to even worry about that. A is negative 16, B is 88, C is 2. So let's plug this into the quadratic formula. It's negative b, so negative 88 plus or minus the square root of b squared, so 88 squared minus 4 times negative 16 times 2 minus 4ac over 2 times negative 16. All right. So that's going to end up being, let's go ahead. I'm going to go ahead, in case you made a calculator error, so you can know what this is supposed to be. So under the radical, it's 88 squared plus, because 2 negatives make a positive, 4 times 16 times 2. All right, 78, 72 is what's under the radical. So I've got negative 88 plus or minus the square root of 78, 72 over negative 32. Okay, so the square root of 78, 72 is 88.72. Okay, so the square root of 78, so that's going to be negative 88 plus or minus 88.72 over negative 32. Okay, so negative 88 plus 88.72 is a positive number divided by a negative, so that's going to be a negative number, so I'm not worried about that. I'm going to do negative 88 minus 88.72. So that's negative 176.72 over negative 32. That'll give me the positive number. Your time has to be positive, so you're going to get two solutions here. I'm not even bothering with the negative one. So divided by negative 32, and you're going to get 5.52 seconds. So that is quite a boot of her pre-calculus notebook. I do believe it would have hit the ceiling before it landed, but you know, yeah, if you can kick your notebook into the air and it's 5.5 seconds in the air, then you should try out for an NFL team to be their punter, because that is one heck of a punt. All right, last question of this lecture. So it says, Ellen kicks a stone off the edge of a tall cliff. The distance d between the rock and the ground t seconds after being kicked is d is equal to negative 16t squared minus 6t plus 480. How many seconds elapse before the rock is at a height of 424 feet above the ground? All right, well, the distance d between the rock and the ground is going to be 424 feet. So, oops. So we're still in 2.7.2. So we have this equation, d, that's distance above the ground, is equal to negative 16t squared minus 6t plus 480. And what the problem says is how many seconds, so we want to solve for t, before the rock is at a height of 424. So we have 424 is equal to negative 16t squared minus 6t plus 480. All right, and now we're just going to set that equal to 0. I can tell you now this doesn't factor, so we're going to end up using the quadratic formula. So I'm just going to set it equal to 0. I'm not going to worry about what the positives and the negatives. Subtract 424 from both sides. You have negative 16t squared minus 6t. And then 480 minus 424 is 56. So excuse me. So I'm subtracting 424 from both sides so I can set it equal to 0. So A is negative 16, B is negative 6, C is 56. So I'd have negative B, that's negative negative 6, which would be positive 6, plus or minus the square root of negative 6 squared minus 4 times negative 16 times 56 all over 2 times negative 16. So that's 6 plus or minus, so we would have 36 plus 4 times 16 times 56. So that'd be 3620 all over negative 32. So the square root of 3620 is 60.17. So we'd have 6 plus or minus 60.17 over negative 32. Now, I don't even want to bother with the negative answer because we're trying to get time. So 6 plus 60.7 would give me a positive number, and then divided by negative, I would get negative. So let's do 6 minus 60.17 over negative 32. So it's going to be negative 54.17 over negative 32. So the other answer would be negative. Not going to bother with it. And let's see. And that's going to give me 1.69. So if you did the other root, just X it out. But 1.69 seconds. All right, your homework is going to be worksheet 2.7. There's 4 problems on it. So I really don't have anything to say about those problems. I think this lecture should help you. I will say that number 2 is challenging. So I've had students have some trouble with number 2 because they don't read what the question is asking. So read closely. So I've had students go part of the way and get the time, but they don't end up getting the final answer because it is asking for the average speed. So number 2 is difficult because it's asking for the average speed. So you have to do a little work at the end for number 2. So see if you can get that right. If not, I'll make a video and show you how to do it. So no big deal. And I'll talk to you on the next one.